Have you ever envisioned a full-fledged wind power station that could conveniently fit within the confines of your backpack? Or about a solar panel that doesn't generate electricity but transforms sunlight into hydrogen gas instead? Or even a combination of these? Let me introduce them to you. Meet the Shine Turbine, an ingenious wind generator that enables you to harness electricity even from mild breezes. Weighing a mere 3 pounds, this device can transition from its compact state to operational within just 2 minutes. Its unassuming size belies its capabilities, as it can generate up to 40 watts of power. Powered by a 12,000 mAh rechargeable battery, its primary function is to charge gadgets requiring 5V and 4A specifications. To facilitate this, the turbine is outfitted with 2 distinct USB ports. Interestingly, you need not manually seek out the wind. The generator housing autonomously rotates on its support to align with the wind direction. Sporting an IP54 water resistance rating, it's suitable not only for mountain hikes and forest adventures, but also for waterfront settings and rainy conditions. Transitioning to another innovation, the Solhid Home solar panel offers a groundbreaking way to harness solar energy. Resembling a conventional solar panel, this device doesn't convert sunlight into electricity, but rather into hydrogen gas. With a conversion efficiency of 15%, a global record at present, this hydrogen can be employed for home heating or even refueling hydrogen-powered vehicles. The potential applications of this technology suggest that around 20 such panels on your roof, coupled with well-insulated housing, could efficiently sustain you through the winter. Although large-scale production isn't yet a reality, the prospect of limited-scale manufacturing is under consideration, possibly paving the way for market availability around 2030. Now, envision a hybrid marvel known as OmniFlow, ingeniously amalgamating wind turbines and solar panels. This equipment defies convention by horizontally positioning the generator, akin to an airplane wing, enabling it to harness both wind and solar energy regardless of wind direction. With a maximum output of 3,000 watts, its blades initiate rotation at wind speeds as gentle as 1.5 meters per second, a mere whisper of a breeze. Foreseeing its potential as a streetlight replacement, several test models have already been installed in the harbor of Porto, Portugal. In the upcoming sections, we'll introduce the ZipCharge Go Hub, a portable EV charging system for any location, and we explore the Seaway Kite, presumably cutting maritime fuel consumption by 20%. Then we look into combination of crops and power generation in one plot. Before we proceed, let's delve into the topic of the solar industry and its competitive race to expand rapidly. Recently, Elon Musk unveiled a remarkable breakthrough in the form of a groundbreaking power cell. Changing gears. The solar industry is engaged in a competitive race to expand rapidly, and recently, Elon Musk unveiled a remarkable breakthrough in the form of a groundbreaking power cell. This cutting-edge technology boasts reduced costs and the promise of an infinite energy supply. Familiar to many is the conventional silicon photovoltaic solar cell, exemplified by the black and copper solar panels found on residential rooftops and solar farms, originating from the US in 1950. Presently, crystalline silicon accounts for approximately 90% of all solar panels produced globally, with the market growing at a rate of around 30% annually. Enter Tesla's groundbreaking discovery involving a material that is not only cost-effective, but also lighter and simpler to manufacture. This economical solution yields powerful cells known as ferroelectric crystals, so thin that they hold the potential to power entire houses. The solar industry faces challenges, particularly the cost of crucial components like polysilicon for solar panels, which has soared due to increased demand and manufacturing delays. The highest grade of polysilicon now commands a price of 40.62 cents per kilogram, surpassing the previous year's high of 40.34 cents. The silicon metal used for manufacturing polysilicon is meticulously purified to attain a purity level of 99.999%. To prevent crystallization in the silicon rods forming at the reactor's center, the reactor walls must be kept cold. However, Tesla had to seek an alternative to silicon due to the significant energy expenditure required to maintain this temperature differential. By ingeniously layering thin materials, Tesla managed to amplify the energy output of ferroelectric crystals in solar cells by a factor of 1,000. A distinguishing feature of ferroelectric crystals is their capacity to generate the photovoltaic effect without the need for a PN junction, obviating the necessity for incorporating layers of positively and negatively doped cells. Researchers believe this alteration could streamline the construction of solar panels. Notably, this groundbreaking cell can be crafted without mining raw materials from the Earth's crust. Utilizing ferroelectrics such as barium titanate, a crystalline mixed oxide of barium and titanium, substantially reduces costs. Tesla's approach entails minimized expenditure on highly skilled labor and advanced equipment, thus projecting that these panels could cost up to 10 times less per watt compared to contemporary commercial silicon solar panels. The introduction of this revolutionary technology showcases the constant evolution and innovation within the realm of solar energy. Prior to factoring in the federal solar tax credit, one could expect Tesla solar panels to be priced at approximately 2.21 cents per watt. However, the cost per watt for the new ferroelectric panel stands at a mere 22 cents. Concerns over the cost of silicon solar panels have persisted until this point. While this novel Tesla innovation offers an affordable option for those unable to make large upfront investments, questions arise regarding its actual energy output given its low price point. In the first quarter of 2022, the U.S. added 3.9 gigawatts of solar PV capacity, pushing the nation's total installed capacity to 126.1 gigawatts of direct current, enough to power 22 million homes. New electricity generating capacity in the U.S. surged by 50% during the first quarter, with solar contributing to half of that increment. According to Elon Musk, Tesla's new cell is a game changer, generating more energy than ever before. Researchers achieved this energy boost by crafting crystalline layers of barium titanate, strontium titanate, and calcium titanate. This layered structure facilitates the separation of positive and negative charges within a single solar device with alternating stacks of these materials. This configuration has the potential to significantly enhance the efficiency of solar panels. However, a pure barium titanate ferroelectric crystal doesn't absorb sunlight efficiently, yielding a relatively low photocurrent. Through extensive material experimentation, researchers discovered that combining ultra-thin layers of different materials substantially amplifies solar energy yield. This process involves vaporizing crystals using a high-intensity laser and subsequently redepositing them onto carrier substrates. The outcome is a material with 500 layers, measuring a mere 200 nanometers in thickness. Under laser light exposure, the new photoelectric material exhibited a current flow 1,000 times greater than that of pure barium titanate. Even after reducing the base elements in the mixture by roughly 2/3, this enhancement remained pronounced. The interaction between lattice layers resulted in a notably increased permittivity, allowing light-stimulated protons to facilitate electron movement more efficiently. Measurements indicated the enduring strength of this effect over a 6-month period. An immense 11.34 kilowatt Tesla solar array boasts a daily output range of 43 to 58 kilowatt hours. This pales in comparison to the ferroelectric cell's potential, which could yield 1,500 kilowatt hours per week. Remarkably, this translates to an astonishing 5 million kilowatt hours on a weekly basis, an impressive testament to the energy-generating prowess of this innovative technology. Lastly, consider the Skegness device, an unconventional wind generator that introduces yet another approach to energy harvesting. Imagine a turbine standing at a stature of 6 feet, standing tall in a vertical orientation. This remarkable technology, hailed by its manufacturer as a harbinger of green energy revolution, bears the moniker Skegness. Unconventionally omnidirectional, these turbines eschew the need for rotation, adeptly capturing wind from every conceivable angle, rendering them virtually maintenance-free. Effortlessly hoisted onto rooftops via standard cranes, their silent operation and vibration-free nature render them unobtrusive within inhabited spaces. These turbines offer an array of applications. Their unobtrusiveness extends to indoor settings, making them suitable even for installation within structures. Furthermore, they can be seamlessly integrated with a home's electrical grid, serving as an auxiliary or backup power source. As of now, this technology remains within the testing phase. A Skegness turbine graces the eponymous pier, illuminating a historical landmark during the night. On a factory's rooftop, another turbine contributes lighting to a designated section. Shifting gears, consider the issue of waning battery capacity in electric vehicles. As electric car batteries lose their potency over time, their disposal becomes a costly necessity. However, B2U Storage Solutions, a startup, has ingeniously repurposed these batteries, extending their service life. Electric vehicle batteries from well-known brands, once relegated to car propulsion, now bolster California's energy infrastructure. Rejuvenated to an impressive 85% of their original capacity, these batteries morph into an additional energy storage system, breathing new life into the realm of sustainability. This advancement notably slashes the expenses linked to the storage of electricity produced by solar and wind facilities. The company, boasting access to a collection of 1,300 used electric vehicle batteries, has ingeniously repurposed them as a supplementary energy storage solution. This collective repository of batteries is intricately integrated into a solar power station nestled within the city of Lancaster, California. While the technology remains in its nascent stages, its potential to leverage countless used batteries in the future is indeed promising. Maintaining the focus on electric vehicles, allow us to introduce the ZipCharge Go Hub, a portable modular charging system tailored for these vehicles. Characterized by its modular design and adaptable dimensions, this charging station is versatile enough to thrive in various locations, whether it's a parking area adjacent to office complexes or within residential precincts. It is offered in variants with either 5 or 10 portable charging units, both of which fit seamlessly within standard parking spaces. These units can be situated on sidewalks or in proximity to existing electricity sources. Operating 24/7, the charging units within the Go Hub can be rented at any time. The process is user-friendly. Upon approaching the designated compartment, the structure's door automatically opens, allowing the user to retrieve the charging unit, connect it to their vehicle, and subsequently return it to the compartment upon charging completion. Transitioning to marine transportation, the implementation of green energy technologies extends beyond land vehicles. A striking exemplar is the Seaway Kite, a creation of the French company Airseas. With a sprawling surface area spanning 1,640 square feet, this aerial kite plays a pivotal role in maritime operations. Its expansive surface area furnishes supplementary thrust, thereby alleviating the burden on the ship's main engine. This innovation exemplifies the seamless fusion of green energy practices within the realm of waterborne transportation. Developers project that this airborne kite technology can effectuate a notable reduction in fuel consumption and carbon emissions, with potential gains of up to 20%. The streamlined installation process is another compelling feature, allowing this innovation to be easily retrofitted onto various vessels in a matter of days. Proving its mettle, the technology is already undergoing successful testing on the cargo ship Via de Bordeaux, which navigates the Atlantic Ocean while transporting aircraft components. This trial serves as a precursor to the impending rollout of a full-scale serial version of the kite, boasting an expanded surface area of 3,280 square feet. The quest for suitable locations for solar panel deployment has become increasingly challenging, often encroaching upon fertile land. Voltalia introduces an ingenious solution via their agroelectric station, aptly named Cabanon. This innovative system marries agricultural crop cultivation with concurrent green electricity generation within the confines of a single plot of land. Situated at approximately 15 feet, the solar panels not only harness solar energy, but also serve as a protective canopy against inclement weather conditions, safeguarding the crops. The system's design accommodates the unimpeded movement of machinery necessary for the crop cultivation process. Boasting a potential power generation capacity of up to 3 megawatts, Cabanon can cater to the energy needs of more than 4,000 individuals. Encompassing an area of 4.5 hectares, the project's implementation carries an estimated cost of €700,000. The query of which technology exhibits the most promise is indeed thought-provoking. Your insights on this matter are highly valued. Kindly share your opinions in the comments section. Additionally, ensure you've subscribed to our channel to stay abreast of the latest captivating technological developments. An array of captivating information from the world of technology is on the horizon.